on May 30th, 2023, China begins drilling a 10,000-meter hole into the earth in the Tirim Basin, more than 6,000 kilometers from its eastern coast. Not for oil, not for gas, but to reach rock that has not seen the surface in hundreds of millions of years. That is not just a drilling project. That is a direct attempt to touch the boundary of the planet itself. And the deeper it goes, the stranger the questions become. If you are into stories like this, hit a quick like and subscribe so you do not miss the next one. By the end of this video, you will understand why drilling to the mantle matters, how China is attempting something no country has successfully completed, and what this means for the balance of power on Earth. The layer no one can tech. The Earth looks solid, stable, predictable. But beneath your feet, just 35 kilometers down on average, lies a boundary humanity has never crossed. The mantle. That boundary is called the Mohorovičić discontinuity. Scientists shorten it to the MOHO. It separates the crust from the mantle, like the thin skin of an apple covering a dense interior. For over 70 years, countries try to reach it. The Soviet Union drills the Kola super deep borehole, reaching 12,216 meters. To put that in perspective, that is deeper than Mount Everest is tall. But they stop. Temperatures hit 180 degrees Celsius. Rocks behave like plastic. Equipment fails. America tries in the 1960s. Project Mohole. Budget explodes past $73 million. To put that in perspective, that is equivalent to more than $700 million today. The project collapses before reaching even half the required depth. Japan attempts offshore drilling. Costs spiral. Technology stalls. And the MOHO remains untouched. That is not just a scientific gap. That is a boundary humanity cannot cross. But here is the thing nobody talks about. The deeper you go, the less the Earth behaves like rock. It flows, it bends, it fights back. So the real question is not whether China can drill deep. The question is, what happens when the planet pushes back? The Earth is not just ground. It is resistance. The impossible to Taft drilling sounds simple. You spin a bit, you go down, but the reality is far more brutal. China's target depth is 10,000 meters. To put that in perspective, that is stacking 30 Burj Khalifas end to end beneath the surface. Temperatures at that depth reach 200 degrees Celsius. To put that in perspective, that is hotter than most industrial ovens. Pressure climbs to 1,300 atmospheres. To put that in perspective, that is like having 1,300 elephants standing on a single square meter. Rock layers are not uniform. They shift from sandstone to granite to salt layers, each behaving differently. Drill bits wear out every 200 hours. To put that in perspective, that is less than 9 days of continuous work. The drilling string can stretch over 9 kilometers. Think of it like trying to push a wet noodle straight down without bending. Fluids must circulate constantly to cool the system. Think of it like running cold water through a boiling kettle that never turns off. And then there's deviation. A small angle error at the top becomes a massive miss at depth. Like aiming the laser slightly off target and missing by kilometers. Now stack the obstacles. Extreme heat, crushing pressure, unpredictable geology, tool failure, cost overruns, decades of failed attempts, no proven path. None of that stopped the builders. Here is the part that blows people's minds. The hardest part is not going down. It is staying straight while doing it. And that is just the beginning. Depth is never just depth. The machine that eats stone. China approaches the problem differently. Instead of brute force, they design a layered system of precision drilling. The rig itself stands over 83 meters tall. To put that in perspective, that is roughly the height of a 25-story building. They use a specialized drill bit with diamond composites, harder than almost any natural material on Earth. Think of it like using a knife that sharpens itself every time it cuts. The drilling fluid is engineered to withstand extreme heat while carrying crushed rock back to the surface. Think of it like blood flowing through veins, cooling and cleaning at the same time. Sensors run along the drill string, measuring pressure, temperature, and direction in real time. Think of it like a GPS system navigating in total darkness. Simple in theory, incredibly hard to execute. And then comes the part that sounds impossible. The drill does not just go straight down. It adjusts direction mid-drill, correcting itself thousands of meters underground without human visibility. Think of it like threading a needle while blindfolded and doing it from kilometers away. China also drills through 10 layers of continental rock, some formed over 540 million years ago. To put that in perspective, these rocks existed before trees appeared on Earth. That is not just drilling, that is traveling through time. And after each section, steel casing is inserted to prevent collapse. Think of it like building a tunnel wall brick by brick as you dig forward. Think about what that actually means. Every meter requires precision. Every error compounds. But here's the thing nobody talks about. This is not the deepest hole ever attempted. It is the most controlled, and that changes everything. Control is more valuable than depth. The secret no one says out loud, but all of that misses the deeper point entirely. This was never really about drilling a hole. And that brings us to the secret purpose of this project: data. The deeper you go, the more information you collect about the Earth's structure, mineral composition, and thermal behavior. That data has direct implications. Energy. Geothermal energy becomes viable when you understand deep heat flows. A single high-temperature well can generate megawatts of power continuously. Minerals, rare earth elements, often exist in deep geological formations. Mapping them gives long-term resource advantage. Seismic prediction. Understanding stress points in the crust improves earthquake forecasting models. Think of it like reading the blueprint of a house instead of guessing where the walls are. That is not just science. That is strategic intelligence. And then there is another layer: technological dominance. The ability to drill deeper, faster, and more precisely translates into oil, gas, and underground infrastructure advantages globally. Think of it like mastering a tool that others cannot even use yet. Here is the part that blows people's minds. Whoever understands the Earth's interior first gains leverage over energy, resources, and risk prediction for decades. That is not just geology. That is power. But here's the thing nobody talks about. Most countries stopped trying. China did not, and that changes the entire equation. The ground holds more than rock. The world that watches Q Ketley now zoom out. This is not a single hole in the desert. This is a signal. Whoever does this first does not just reach the mantle, they unlock a new layer of planetary understanding. For generations to come, energy systems could shift from fossil fuels to deep geothermal networks. Supply chains could move toward underground resource extraction that bypasses traditional mining. Earthquake prediction could move from reactive to proactive. Think about what that actually means. Cities could be designed differently. Infrastructure could be safer. Energy could become more stable. But none of this happens overnight. None of this happens in a single dramatic moment. It happens slowly, quietly, 1 meter at a time, and the world is watching. Some see a scientific breakthrough, others see strategic positioning. Both are true. We will keep tracking how this develops and what it means for the rest of the world, because this is not just about reaching deeper, it is about understanding more. And whoever understands more leads. Progress is measured beneath the surface. I spent hours going through geological reports and engineering data to bring this story to you. If you found this fascinating, hit the like button and tell me in the comments, do you believe this is purely scientific exploration, or is it a strategic move for global advantage?